Let's get started with today's lesson. We're gonna be starting with Euclidean transformations. So this topic is gonna be about transformations, and it might include some geometry. So let's get started. I'm gonna move this. All right. What is a Euclidean transformation? Right. A Euclidean transformation is either a translation or rotation or reflection. This gives you a really good example. This is a reflection in this case, reflecting this object over this line. I'm gonna do a much better color. This is the line of reflection. I'm reflecting this object over that line. Alright? Okay, so basically the object is gonna be reflection is this, and then we're reflecting with this part. Okay? And you can see it's a translation, rotation, and reflection. In Euclidean transformation, all lengths and angles are preserved. This is a very, very important fact, as it tells you that this shape is congruent to that shape. Because no matter if it's a translation, rotation, or reflection, it's the the transformed figure is similar and congruent to the original figure, as we can see over here. A rotation means turning around a center. The distance from the center to any point stays on the shape stays the same. Every point makes a circle around the center. This seems like it's also a rotation. And then notice that some rotations have reflections, and the line of reflection is the angle bisector, or the line that makes the angle split in two. A reflection is a mirror image of itself, like a flip. In this case, we're like moving, like pretend you have a paper and you fold it into two. Yeah, you're making a reflection, and each side of the fold are the same or are congruent. And translation is just moving the object. Translation simply means to moving without rotating, resizing, or anything else. Just moving. To translate a figure, every point of the shape must move the same distance in the same direction. When transformations are done in a coordinate system, it's called a coordinate system transformation. So right now in this session we're gonna be talking about these. So these are just some common transformations that you should understand. I don't think you really need that much of memorization. These are really much of them you could derive. So this is gonna be probably pretty easy for the derivation. And as you can see, these are just formulas. I'm not gonna delve right deep into it. I can show you this one. And the reflections of the x-axis is just, remember our x-axis, obviously this is our x and this is our y. We're just drawing that long big. This is our 0, 1, 2, 1, 2, -1, -2. You can see this picture, right? Oops, I'm gonna just scroll down. Do it. Say we're reflecting the point 0, comma 1. I mean 1, comma 0, I'm sorry. So we're reflecting this point, 1, comma 0, and this is the origin. This is -1. So try to understand this part. Like, if it's -1, this tells you that we're reflecting over the x-axis, as we talked about before. X0, the x0, and then negative x0 and y0. So reflecting around the x-axis gives you negative x0 and y0. Let's prove this. Consider a reflection. Let's say this is x0 and this is 0. Then the other side, that gives you the same length and the same orientation. As you can see, say this is x0. These lengths are congruent and they're going in the same direction. Alright, across this line. Well, it's relative to this line right over here. Relative to this line right over here, you see. They're going in the same direction and they're congruent. That is considered a reflection. So this means And no matter which y point doesn't matter because it's reflecting across the x-axis. I mean, this is a y-axis actually. They might have messed it up, but anyways, but still, they're literally just images that reflect across each other. So basically, it's the negative in this case. And same for the y. That's basically all you need to know. It's just like for the different types of lines, they're basically the same thing, same logic. All right, let's move on with example one. I'll let you guys have a try on this question and tell me your answer to chat in private message, please. Sorry guys, somehow it's not working right now. Okay, there we go. So the answer was A. Right. So basically, why was it A? Because it's a reflection of the y-axis, and the y-axis over there. If we're reflecting it, we're basically taking the inverse of the x-coordinate, which is just -5/3, or A. Oh, I'll just chat. Anyways, let's try example 2. I'll let you guys have a try this question and tell me answers through chat. It's pretty similar, but a bit a step on the difficulty. Okay, let's get started. So the answer was A. Why? Because imagine if this is y equals -2. And this is uh the x-axis and this is -5 right at this point. This distance from the y line is 5 because from 3 to -2 is 5. And 3, so basically we're gonna have to go down another 5 or -5 to get -5, -7, right? Or A. So now I'll let you guys have a try on example 3. I'll let you guys have a try on this question and tell me answer to chat. Well, let's get started. So, so now how are we supposed to be doing this question? So think about it like this. So 5,3 reflected from the line 2. X equals 2. Now, 5 is the distance from to 3. And then 2, another point that is the same on the same line in 5,3 that is also 3 away from x equals 2 is -1. Now, Now for y equals 2, 3 is 1 away from 2. So the reflected is going to be 1 away from 2 or 1. So -1, 1 is our answer. Add them up, you get 0 or B. Now I'll let you guys have a try this example 4. It might be a bit trickier, right? But there's a key thing that you should understand. And then you're going to get a really easy answer. It has a one step just to get a solution. I'll let you guys have a try in this question and tell me answer to the chat. Alright, let's get started with discussion. So I hope you guys found out uh the the method to solve this question is really fast. And it's just because y equals x. What does y equals x mean? X is equal to y. So the x coordinate is equal to the y coordinate. So basically they're swapped. All you have to do. Because y equals x, meaning that x equals y, so 5 is the new y coordinate. 3 is the new x coordinate. And then boom, the y coordinate is 5. And it was pretty much that easy. I, I hope if you want to memorize it like this, that's basically the formula how it's supposed to be doing it. Now let's get have a try on example 5. It might be slightly different. But remember about the mapping. Like, what does it do? Y equals -x. Look at the y coordinate. And then look at the x coordinate by making it x equals -y, right? I'll let you guys have a go on this question and tell me answer to chat. All right, let's get started. So Johnny was the only person to get it right. So basically, how you're supposed to do it, as I told you, just plug in. So y is negative x. So you see this is x. We take the negative of that, and that'd be y. So that'd be 3. Same thing. X is negative y, or be 4. So the y coordinate is gonna be 3 or b. It's just plug. Now 6 might be a bit harder. A graph of the problem y is equal to x squared minus 2. We reflect with respect to y equals negative x. Write the equation of the resulting graph. It's actually pretty hard. I'll actually give you guys 15 minutes because this is actually pretty hard. I think you should use Desmos graphing calculator. You try to use graphing calculator to see. It's online. It's just Desmos graphing calculator. Just try to see what's happening. Like what happens when you do it. And then notice what we did before. And we plugged in. Okay, nice. You're using Desmos, but it's not good. The rest, the before questions don't need to use Desmos. This one you could use Desmos, but remember what we were doing before. We're plugging in into this function right over here. Plugging it right here. Now let's try doing it in example 6. What do you get? I think it might be much easier. Alright, you guys ever tried this question and tell me answers to the chat. Alright, so here I have Desmos graphing calculator right here. And we can go over here and we're gonna test out what we see, right? So y is equal to x squared minus 2. You see this, right? Now we're gonna make y equals negative x. Imagine we're reflecting this, alright? We're reflecting this over. What does this give you? Let's test it out. If we plug in, we get y is equal to negative x squared plus 2. Am I right? But that's just a reflection. Yeah, so basically what would you let that was a reflection over the x-axis. Take the negative. Now we're taking a reflection over y because negative x. What do? Remember, we swap. X equals y, we swapped it. Like, say this was our polynomial right over here. We have the red one, the color red. Now, imagine if we were reflecting it over y equals x. You see this? Imagine flipping it. This point is gonna be at the same point, but like on negative two x equals negative 2. Because this point was on with the y coordinate of negative 2. So this point will now lay on the x coordinate of negative 2. Right? And similarly with these points. These 2 points stay on the line because they're on the line already. So if you reflect it, it's gonna still be the same. Now, what's the graph that is just reflected? Well, since y equals x, we swap them. So it becomes x equals y squared plus 2. Oops. Oh, y squared minus 2. As you can clearly see, it's indeed a reflection. You can see these are completely congruent. But like, totally different things. Alright? Now, imagine yourself the same thing, but with y equals negative x. What do we do from there? Now, notice that we will swap and then take the negative. Because since y equals negative x, this y over here, you can see when I'm clicking the cursors at, y will become x, but actually negative x, which is the negative, and the x will become negative y squared. But since negative y over that, we're gonna be taking this watch. Oops. Negative y squared. But since negative y squared is just y squared, we get negative x is equal to y squared minus 2. And you can clearly see it's indeed a reflection over this line. So that's one of the most key things to understand here. Like, it's basically a plug-in for this case. All you have to do. Now for other lines, it's kind of different. It's a different thing, alright? For these reflections over these lines, yeah, it's basically like this type. Alright, let's move on. Oh, so the answer to this question was uh more standard form y squared minus 2 is equal to negative x. Right, yeah. Now let's have you get a try on example 7. Right? Let's go try this question and tell me answers to chat. Well, let's get a try of this question. So basically, how we're supposed to be solving this is that it's been reflected. So basically now this side is congruent to that side. And this side, these these are just the midpoints. Now you want to see the height. So basically since we got the y coordinates, we know the height, which is this. H is equal to 3 to 1, this is just 2. What's the other two bases? This is a trapezoid. This is 4. It's double 2. So it's the distance from y-axis. Same thing for this one. It's a 10. Adding them up, divide by 2. Basically, a plus b divided by 2. So this is a, b, the two bases divided by 2, or the average, times 2. Cancel out, since the height is 2. And then you get 10 plus 4 is 14, so the answer is 14. So it's D. Now let's try example 8. Let's give them a try on this question and tell me your answers to chat. I'll give you guys 2 more minutes, all right? All right, let's get started with this question. So the answer was E. All right, let me show you how you get into the answer. All right, so here we go. Here's the graph. We got this triangle right over here, and then we're gonna find the reflection. One way to do it is just notice that to get from -2, 2 to 0, 1, we have to go 1 down and 2 to the right. So to get the reflection of it, we have to also do 1 down, 2 to the right, or we get 2, 0. And the answer, which is E, which is indeed 2, 0. Another way to do it is find the line that goes through this -2, 2, goes through this point. Because the point and the reflection go on the same line. And the important thing about it is that it's the perpendicular bisector. And technically it's not the bisector, but a perpendicular. But bisects the segment that connects the reflections, like bisects the segment gets bisected by the reflection. So from there, we can get that we find the graph, the perpendicular of 2x is -1/2. It's basically the reciprocal of the negation, which is just -1/2 x. Now we put in as a coordinate to find the y-intercept, or to find the intercept to make it find the line, basically the slope of the, basically what the line is. And we get 1 is the right answer for the intercept. And we get that 2, 0 is the correct answer. So both of them work. So the answer is E, basically. These are the two ways. I hope you guys have a great time. I'll see you guys in the next session. I hope you had a good night. Good night. Have a great day.